Welcome back to the workshop. We want to continue taking a look at section 4.2, paths and circuits. And we want to utilize the Euler circuit algorithm to find an Euler path in our next example. All right, the Euler circuit algorithm, of course, is used to find an Euler circuit. And it requires that each vertex be of even degree. So how does this really work? What have we got going on here? Well, the key is to make one very particular observation. So if we have, well, let's check out all of the degrees first of all. So this has degree 1, 2, 3, 4. So that has degree 4. Degree 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 1, 2, 3, 4. That's not 3, that's 5. 1, 2, 3, 4, 5. Excellent. So we see that they're not all even degree. What do we do? Well, what we do is we actually add an edge between the two odd degree vertices. That would make this one degree 6, and that would make this one degree 4. Once we've done that, we have all even degrees. And if we make this edge the very first edge that we travel, then we'll go ahead and find ourselves an Euler circuit using the Euler circuit algorithm. And then we delete that edge from our circuit because it's not an actual edge of the graph. Once it's deleted, we of course are left with an Euler path that does travel all of the edges in the actual graph. Okay. All right, so let's get rid of all of this for a moment and start by labeling our vertices. Okay, we could give the edges, which we will do. We do have to do that because it is a multigraph. So we will have to keep that in mind as we go along here. Multigraph, so we do need the edges. All right, cool. So we add our edge in and we label it. We'll label it Z. And then we're going to follow along with the Euler circuit algorithm to find our Euler path. So we find the Euler circuit on this adjusted or this new graph, multigraph. And then once we have that circuit, we remove this edge and we're left with an Euler path. All right, so I would like to follow along with the steps of the Euler circuit algorithm. And step 1, if we refer to the previous page, step 1 is to start the path. Okay, so we're going to choose a starting point. That's what I'll label it as. So choose a starting point. And when we do this, we're also going to give the collection of edges. So we're going to choose the starting point to be D. Excellent. So choose vertex D, start at D. And then we want to specify what the edge set is in this case. So we have A, B, C, D, E, F, G, H, I, J, K, M. There's no L here, and we're adding in Z. So A, B, C, D, E, F, G, H, I, J, K, no L, goes to M, and we're adding Z. All right, from here, we move on to our next step. We've done what step 1 is, right? Step 1 is to pick out a vertex and list all of the edges, given in the other order here, right? List all the edges and select a starting point. Excellent. Step 2 is where we begin to actually create a path. So in step 2, what we do is we're going to pick a starting point for the expansion, and then we're going to expand at that point, and then we're going to enlarge the actual circuit that we have. So we'll follow along with step 2.1, 2.2, and 2.3. So step 2.1. In step 2.1, we choose an expansion point. All right, so we choose an expansion point. Let's see here. Oh, and you know what? I said I wanted to start at D, but we didn't actually label these to say what vertices these are. So we're going to label them as A, B, C, D, E, and F. Okay. So it should have been clear, or hopefully it was clear, that this is where I wanted to start, since, as I said previously, I want to first travel along the edge Z. All right. So we're going to choose an expansion point, and the expansion point has to start with whatever our path is, whatever our current circuit is. And the only thing we have so far is the vertex D. So we have to expand at vertex D. All right, so we choose the expansion point. Then the next step, 2.2, we need to create the expansion. So where we're at in the process, this would be considered our first try to create our Euler circuit. So let's go ahead and try that on our first try. So I'll make this green for a moment. So on our first try, we are going to start at D, and then we're going to travel Z. So we know we're doing that. Excellent, because I want to travel that first. Now from there, what I'm going to do is I'm going to travel to F along I. Okay, and then I'm going to travel to D along J. Excellent. And I have not used up all of the edges at vertex D yet, so I still can go and continue on trying to use up all of our edges. So I'm going to continue on along edge D to vertex A. Let's see here. Yep, and then I'm going to travel along edge C to vertex C, and then along edge F back to D. Now, of course, it doesn't even look like I really tried to get everything here. And I didn't, because frankly, this is still a small enough graph that we could probably find the whole thing on our first try. But I want to highlight what is going on in the Euler circuit algorithm here. So let's create the expansion. We did it, we just described it. Let's write it down. So the path that we have completed, or the circuit that we have so far, is we traveled from D, and then we started at vertex D, traveled along edge Z to vertex C, then along edge I to vertex F, then along edge J to vertex D, then along edge D to vertex A, and then along edge C to vertex C, and then finally along edge F to vertex D. Once we got there, there was nowhere else we could go. So we have to stop there and move on to the next step. So step 2.3 is trivial. As we're progressing through this the first time, we're going to actually expand the circuit. So officially, our circuit is just D right now. This is the expansion. Let's go ahead and replace that one instance of D with the expansion. So our circuit becomes, sometimes you might want to label it with circuit. Okay, so our circuit becomes, what do we have here? Well, I'm replacing D with all of this. So I'm just going to write it all as that for the moment. So D, Z, C, I, F, J, D, D, A, C, C, F, and D. Okay, so there's our circuit so far. Now, to make sure that we're progressing along, when we create the expansion, we should actually be removing these edges from our edge set. So let's check and see what ones we have used and go ahead and remove them. So we have used Z. Excellent, let's cross that off. We can see that here as well, right? But for the edge set, let's just cross them off so we know what's going on. So Z, I, J, Z, I, J, D, C, and F. D, C, and F. So we've used all of those edges. So once we're done with 2.3, we say, are there any edges left? Yes, there are, right? We have A, B, E, G, H, K, and M. And of course, we could have seen that over here as well. That would be fine. All right. So at this point, let's put this in red. And let's say the edge set is non-empty. So we repeat the loop. Okay, so we're going to repeat step 2. Step 2 is a loop. The actions in that loop are 2.1, 2.2, and 2.3. So we're going to do that again. So we go back and we choose an expansion point. So 2.1, choose expansion point. All right, so when we choose an expansion point, we're just looking to choose a vertex that is in the path already, or that is in the circuit already, that doesn't have all of the incident edges traveled. So A is an option, C is an option, and F is an option. Of course, at D, all of the incident edges have been used. So we pick either A, C, or F. And in this case, let's go ahead and choose F. So let's choose to expand at F. All right, cool. What's the next step? Well, step 2.2. Let's see here. I was labeling these as steps. So step 2.1, step 2.2. We want to create the expansion again. And let's give this expansion in red. My apologies if you're red-green colorblind. You know what? Let's actually make it different. Blue. Green, blue, that's not a concern. Excellent. So we're expanding at F. This is our expansion. Let's see here. Yep, okay. So the expansion that we're going to put in is going to be, what is it? Well, let's travel along K to E. Doesn't really matter what we do here. There's loads of options starting, but I have a particular one chosen already. So let's go from F to E along K, and let's then go along H to C, and then go to B along E, and then let's go up to A, and let's do that by traveling along edge A. Once we're here, we don't really have any options anymore. We have to go back to B along B, we have to go to E along G, and we have to go to F along M. And once we get back to F, all of the incident edges have been used, so we have no options and we can't go anywhere. That is our expansion. So our expansion was to start at F, travel along K to vertex E, travel along edge H to vertex C, travel along edge E to vertex B, travel along edge A to vertex A, travel along edge B to vertex B, travel along edge G to vertex E, and then travel along edge M to vertex F. Excellent. So now in our next step, we go ahead and add that expansion in. So step 2.3 is enlarge the circuit. And what I'm going to do is I'm going to give our initial circuit in, I'm going to give it in red so I can focus on the expansion being added in blue here. So we are looking at this particular occurrence. We're starting at vertex F there. So we have let's see, we need lots of room here. So we have D, and then we went to Z, D, Z, to C, and then along I to F. But F is what we're replacing here. So we are replacing the instance of F with this new expansion. So we traveled along Z to C, we traveled along I to F, and then now instead of going back to D, we're going ahead to travel along the blue portion. Okay. Then once we travel the blue portion back to F, we'll come up to D and then finish our Euler circuit. So get to F, we include the expansion here. So F to K to E, and then along H to C, and then along E to B, along edge A to vertex A, along edge B to vertex B, along edge G to vertex E, along edge M to vertex F. Okay, that brings us back to this point here, and we can finish off the original circuit that we had. Of course, it didn't include everything, but we traveled this first portion, went along this side journey to collect the rest of the edges that we needed to travel, and then we can finish the original circuit. So we have travel along J to D, and then edge D to vertex A, and then along edge C to vertex C, and then along edge F to vertex D. So this is everything, right? We have now used, let's go ahead and remove what we've used. We've used A, B, E, G, H, A, B, E, G, H, K, and N. K and N. So that's everything. So we have E is empty. Move on to step 3. So we have step 3 here, and then we have to actually finish the problem. So step 3 is we can give the circuit, right? Give Euler circuit. And that's exactly what we have here. So I'm just going to repeat that one more time. It's a little bit to copy. So we've got D to Z to C, along I to F, along K to E, along H to C, along E to B, along A to A, along B to B, along G to E, along M to F, along J to D, along D to A, along C to C, and along F to D. All right, excellent. So that gives us our Euler circuit. However, so this is maybe I'll put this in green. However, Z is not an edge of the original graph. So we give our Euler path. We just go ahead and remove dz from the beginning, and the rest of it is our actual path. Yeah, so we'll stay with blue here. So we remove these two and start at C. So our Euler path actually starts at C. Our circuit, which first traveled along an edge that didn't exist, okay? If it's not there to travel along in the actual graph, we added that edge. So we remove Z. We remove the edge Z, so we start at C. So C, I, F, K, E. Of course, I'm just saying the letters here, but it's vertex vertex C along edge I to vertex F, along edge K to vertex E, along edge H to vertex C, along edge E to vertex B, along edge A to vertex A, along edge B to vertex B, along edge G to vertex E, along edge M to vertex F, along edge J to vertex D, along edge D to vertex A, and along edge C to vertex C, and along edge F to vertex D. All right. It's also worth noting, all right, that's a long list here, and this is why it would be an advantage for us to say, hey, look, it's a multigraph, and in multigraphs, we can give a path just by the edges. I, K, H, E, A, B, G, M, J, D, C, and F. Much shorter. So we could have done that as well. Excellent. There is a little bit more to section 4.2, so we'll take a look at that in our next video, but that should be just about it for us. So for now, I'll see you guys later, but soon back here in the workshop.